वॉइस आ रही है ना आप लोग को?
हाँ सर।
हाँ बेटा। ठीक है। अभी आप एक बार कंफर्म करो मुझे सभी लोग, मेरी वॉइस आ रही है अभी? ठीक है। ओके फाइन। तो चलिए सेशन के स्टार्टिंग में दोबारा से करता हूँ बिकॉज अभी तक वॉइस क्लियर नहीं थी, आप लोगों को ऑडिबल नहीं था। ठीक है। तो वेलकम अगेन इन द प्लेटफॉर्म ऑफ गेट ट्रिनिटी, और टुडे वी आर गोइंग टू ऑर्गेनाइज अ गेट एंड बार्क मॉक इंटरव्यू सेशन, जहां पर आज हम लोग बात करने वाले हैं हमारे कुछ स्टूडेंट्स के साथ में जिनका बेसिकली बार्क मॉक इंटरव्यू फेस करने वाले रिसेंट आने वाले आपका मई के एंड और जून के स्टार्टिंग डेज के अंदर में। और इस सेशन के अंदर आज मैं सबसे पहले इंट्रोड्यूस करा रहा हूँ हमारे स्टूडेंट और बार साइंटिस्ट के साथ में रैंकर सेहज आनंद के साथ। सो वेलकम अगेन बेटा।
थैंक यू सर।
So today we are going to arrange a mock interview for those who are just preparing for the BARC mock interview session in the recruitment drive for the June interview sessions। ठीक है। सो वहां पर आप लोग जो भी इंटरव्यू फेस करने जा रहे हो, वहां पर जो क्वेश्चंस का लेवल होगा, जो भी आप एक प्रेशर हैंडल करने के लिए या फिर जो भी आपके एक माइंड सेट होता है उस इंटरव्यू को फेस करने के लिए, वो सारी चीजें जो है ना वो आज हम आपको एक बार फील कराने वाले हैं। और जो भी आपके कॉन्सेप्ट्स का लेवल है, जो आप गलतियां करते हैं, कैसे आपको क्वेश्चंस का आंसर रिप्रेजेंट करना होता है, एक्सेट्रा एक्सेट्रा, ये सभी चीज़ों के बारे में आज हम आपको गाइड करने वाले हैं। ठीक है। तो इस सेशन में लास्ट तक बने रहिएगा। और जो भी क्वेश्चंस हम अपने स्टूडेंट्स के साथ में डिस्कस करने वाले हैं, उन क्वेश्चंस का आंसर आप अपने कमेंट बॉक्स में यूट्यूब में भी दे सकते हैं। ठीक है ना। तो आप भी अपनी एबिलिटी के हिसाब से अपने क्वेश्चंस का आंसर दे सकते हैं। तो पहले मैं वेलकम करता हूँ हमारे सभी स्टूडेंट्स का, करण, नवीन और राहुल का। सो वेलकम ऑल बेटा।
थैंक यू सर।
तो गाइज डिफरेंट अप्रोचेस के बाद, डिफरेंट अप्रोचेस का मीन्स मेरा सेंस ये है कि फ्रॉम क्लियरिंग द सीबीटी और थ्रो द गेट 25 स्कोर यू आर शॉर्टलिस्टेड फॉर द गेट बार्क रिक्रूटमेंट ड्राइव। तो इस रिक्रूटमेंट ड्राइव के लिए सबसे पहला चीज एक दिमाग के अंदर आता है, मैं सबसे पहले क्लियर कर देता हूँ बाकी लोगों को, जो भी यूट्यूब के व्यूवर्स हैं, कि इस इंटरव्यू के अंदर में आपका बार का सीबीटी स्कोर या फिर आपका गेट स्कोर कोई भी मायने रखने वाला नहीं है। द ओनली थिंग मैटर्स इज द आपका इंटरव्यू कितना बेटर जाता है। ठीक है ना। तो सेहज ऑलरेडी उस फेज से निकल चुका है। लगातार वो पिछले 1 महीने से सारे के सारे जितने भी जूनियर्स उसके हैं और कलीग्स को वो लगातार मेंटर कर रहा है, गाइड किया उसने, और एक अच्छा खासा उसने चीज़ों को एक स्टडी मटेरियल के फॉर्म में आप लोगों को अपना एक्सपीरियंस भी प्रोवाइड किया है। जो लोग लगातार ग्रुप में कनेक्टेड हैं वो लोग उन चीज़ों का बेनिफिट ले रहे हैं, और उम्मीद है कि ये चीज़ें आपको आपके इंटरव्यू तक पहुंचने में बहुत ज़्यादा हेल्प करने वाली हैं। ठीक है। तो सेहज एक बार इंटरव्यू का थोड़ा सा एक ब्रीफ इंट्रोडक्शन आप दे दो, बिकॉज लोगों को पता है लेकिन एक्चुअली इंटरव्यू का वहाँ माहौल क्या होता है वो थोड़ा सा एक बार आप ब्रीफ कर दो, बिकॉज बहुत सारे लोगों के लिए चीज़ें नई होती हैं, उनके अंदर एक प्रेशर होता है, डर का माहौल होता है, ठीक है ना? बार्क के नाम को सुनते ही वैसे भी थोड़ा-सा डर लगता है। तो कैसे उन लोगों को चीज़ों को फेस करना है, कैसे मेंटली पहले प्रिपेयर करना है, कॉन्सेप्चुअली प्रिपेयर तो बंदा कर लेता है। तो ओवर टू यू सैयद।
जी सर, तो बीआरसी के इंटरव्यू का पहले तो एवरेज ड्यूरेशन लगभग 1 आवर का होता है एंड ऑन एन एवरेज 5 पैनल मेंबर्स होते हैं उसमें। एंड आपको अपने जो 5 मेन सब्जेक्ट हैं, हीट ट्रांसफर, मास ट्रांसफर, फ्लूइड मैकेनिक्स एंड सीआरई, तो एंड थर्मोडायनेमिक्स, ये 5 में से आप मिनिमम 3 आपको प्रिपेयर करके जाना होता है। तो वो सबसे पहले आपसे फेवरेट सब्जेक्ट्स पूछेंगे, तो फिर आप उनको अपना फेवरेट सब्जेक्ट बताएंगे, तो वो ऑर्डर में, उसी ऑर्डर में आपसे क्वेश्चंस पूछेंगे। तो क्वेश्चंस कैसे रहते हैं कि सबसे पहला तो बेसिक क्वेश्चन होता है, बेसिक क्वेश्चन होते हैं, तो अगर उसमें आपने अच्छे से आंसर दे दिया तो फिर वो आपसे थोड़ा एडवांस क्वेश्चन पूछेंगे, कोई क्वेश्चन पूछेंगे, फिर उसी में वेरिएशन करते रहेंगे। तो आपको एक तो उन वेरिएशंस को समझना है, और अगर आपको समझ नहीं आ रहा कि आगे अप्रोच कैसे करें उस क्वेश्चन को, तो फिर वो आपको हिंट्स भी देंगे, तो आपको वो हिंट्स को अच्छे से भी पकड़ना है। तो मेन ओवरव्यू सर ये होता है।
So basically, the interview will start with some basic questions, and if you are able to do the answer of that particular question, then they will move forward for the level 2 questions or level 3 questions, or they will also move to the next subject also. So depending upon your order of preference of the subjects, what you have told during the interview, so they will ask the question from that particular question subjects, right? So be prepared for the subjects which you are telling to your interview panel. राइट। तो जो भी सब्जेक्ट्स अपने इंटरव्यू पैनल को बता रहे हैं उसमें आप कॉन्फिडेंट होने चाहिए, उसमें ऐसा कुछ भी नहीं होना चाहिए कि सर ये वाला सेक्शन मेरा नहीं आता, ये वाला सेक्शन मेरा वीक है, एसेट्रा एसेट्रा, ऐसा कुछ भी नहीं होना चाहिए। एंड जैसा कि सेज ने ऑलरेडी बताया, दे विल गिव यू द हिंट ऑल्सो, इफ यू आर जस्ट एबल टू ग्रैब दैट पर्टिकुलर हिंट, देन यू विल बी एबल टू आंसर दैट पर्टिकुलर क्वेश्चन ऑल्सो व्हाट दे आर आस्किंग, राइट। तो चलिए स्टार्ट करते हैं इस सेशन में। तो सबसे पहले मैं एक बार आप सभी का ऑर्डर ऑफ प्रेफरेंस जानना चाहूंगा। सबसे पहले फर्स्ट ऑफ ऑल, करण, व्हाट्स योर ऑर्डर ऑफ प्रेफरेंस ऑफ द सब्जेक्ट्स?
सर मेरा पहला सब्जेक्ट रहेगा हीट ट्रांसफर,
ओके।
सेकंड रहेगा फ्लूइड मैकेनिक्स,
ओके।
थर्ड रहेगा सीआरई।
Okay, and Naveen, what's your order of preference of the subjects?
So fluid mechanics first, second is chemical reaction engineering, third heat transfer.
Okay, and Rahul, what's your preference order?
So my first subject will be heat transfer, second fluid mechanics, third CRE, and sir, I'm thinking for my fourth subject to be thermodynamics or mass transfer. Depending upon the situation, I will change at the last moment, sir.
Okay, thermo or mass, right?
Yes.
So let's start with the Rahul. So first of all, Rahul, can you introduce yourself?
Yes, sir. Sir, I am Rahul Devpal. I have completed my BTech in 2024 in chemical engineering from BIT Center Dhanbad. This year, I have got AIR 72 in GATE Chemical Engineering, and I have cleared BARC Training Scientific Officer exam, as well as I have cleared the Training Scientific Officer from BARC Technical exam and from the GATE rank also.
Okay, so you are just scored the best rank at a 2-digit rank. So why
Yes,
you
sir.
wish to join the BARC? There are several other options available in the PSUs. So why BARC?
Sir, basically the main reason is behind our nuclear energy corporation. As in future we are progressing towards the green energy, so nuclear energy is the viable option for this cause.
Okay, so have you completed your graduation from the BIT Sindri?
Yes, sir.
So, do you know Scenery is famous for anything else?
Yes, sir. Apart from fertilizers, sir, there are many coal fields over there, sir.
What is the famous fertilizer there located?
What, sir?
What is the famous fertilizer located there?
So fertilizer HURL, sir. We have a plant over there, and there are many coal fields over there. So mainly there are BCCL coal fields over there, which
Okay,
give us the coking coal for steel production.
right. What's your hometown?
Sir, Dhanbad.
Dhanbad. Dhanbad is also famous for the coal mining and
Yes, sir.
other exploration minerals also.
Mm-hmm.
Okay. So, Karan, can you introduce yourself?
Sir, my name is I completed my BTech in chemical engineering from NIT Rourkela. I am just happy interview I have prepared for you in the BARC exam. My was
करण आपका
was
वॉइस प्रॉपर नहीं आ रहा है, मुझे लग रहा है कुछ नेटवर्क इशू है।
हेलो, अभी आ रहा है सर?
ईयरफोन
हाँ हाँ
लगा लो।
हेलो सर, अभी आवाज आ रहा है?
हाँ अभी आ रही है, आप बोलो।
हाँ सर, माय नेम इज करण दुबे। आई हेयर फ्रॉम झारखंड from NIT Rourkela. I have been selected for BARC interview through my GATE score, which is 814 and is AR.
करण बहुत ज़्यादा नेटवर्क इशू है आपका, प्रॉपर वॉइस नहीं आ पा रही है, रुक रुक के वॉइस आ रही है। अभी आप जहाँ पर भी हो वाईफाई या फिर स्ट्रॉन्ग नेटवर्क कनेक्शन नहीं है क्या वहाँ पर?
सर नेटवर्क तो है सर, मतलब
अगर पॉसिबल हो तो आप
सर
लैपटॉप से ज्वाइन कर लो।
इसलिए सर लैपटॉप तो सर रिपेयर करने के लिए दिया हूँ, फिलहाल नहीं है अभी।
बिकॉज वॉइस का बहुत ज़्यादा इशू आ रहा है ना, वॉइस क्लियर नहीं आ पा रही है, बिल्कुल भी क्लियर नहीं आ रही, बहुत ब्रेक हो रही है। शायद आपके पास आ रही है क्या वॉइस राहुल के करण की?
नहीं सर, ब्रेक हो रही है मेरी।
सर मेरी में भी पूरी ब्रेक हो रही है।
एक बार करण अपना वो माइक्रोफोन सेटिंग्स चेक कर लो कि उसमें जो माइक्रोफोन ऑप्शंस होंगे तो उसमें ईयरफोन वाला ऑप्शन आपने सिलेक्ट किया है।
और ANC चेक कर लेना, ANC से कभी कभी प्रॉब्लम आ जाता है।
हाँ करण आप तब तक अपना सेटिंग करो, है ना, तब तक हम नवीन से बात करते हैं। नवीन, आई थिंक देयर इज लॉट्स ऑफ डार्क अराउंड यू, व्हाट हैपेंड, द लाइट हैज गॉन?
Sir, in Chennai it is heavy downpour, sir, so power cut.
Okay, so Naveen, can you introduce yourself?
Yes, sir. Good evening, sir. I am Naveen Kumar. I have completed my BTech Chemical Engineering from 𝐻𝐿 Engineering College. I have cleared GATE 2025 with an AR of 225, and I also cleared BARC CBT exam with a score of 149, sir.
Okay, what's your hometown?
Chennai, sir.
Chennai. So have you appeared for the BARC interview earlier also?
No, sir.
First time.
Yes, sir.
Okay, Sehaj, start with the some technical questions.
तो फ्लूइड मैकेनिक्स से स्टार्ट करें सर।
हाँ करण, क्लियर हुआ? एक बार चेक करना जरा। चलो करण तब तक सेटिंग कर रहा है, अब स्टार्ट करो, है ना।
हेलो सर, अभी आवाज आ रहा है?
हाँ अभी तो आ रही है, सही आ रही है। बाकी आप जब रेगुलर बोलोगे तो पता चलेगा कि उसमें कुछ लैगिंग है या फिर नहीं है।
ओके
सर लैग कर रहा है पूरा।
लैग कर रहा है, ठीक है। करण एक बार आप सेटिंग कर लो प्रॉपरली, है ना, फिर हम लोग आपसे क्वेश्चंस पूछेंगे। बिकॉज क्वेश्चंस में भी हमारे आप तक क्लियरली पहुंचेंगे, बट आंसर्स हमारे पास क्लियर नहीं आ पाएंगे आपके, है ना। सो देयर विल बी सम डिफिकल्टीज और लिसनिंग आल्सो।
ओके सर, ओके
है
सर।
ना, एक बार अपना थोड़ा सा उसको देख चेक कर लो आप, नेट स्पीड वगैरह क्या है ना। चलो Sehaj, we start with the technical questions, ठीक है ना। So we'll ask questions from both of you because most of the subjects are common and the sequence is something how change, so don't worry about that. So we'll ask the same questions, ठीक है ना। You can answer the type of questions as per your knowledge and expectations, ठीक है ना। Don't just think that he has answered that particular term and I can't include that particular term, ठीक है ना। तो आपको जो भी नॉलेज है उसके बेसिस पर आप आंसर कर सकते हो। ओके नवीन? We'll ask the same questions from both of you, okay na? And you can be able to answer that particular questions as per your knowledge, right? And if there is you need any implementation, then we will tell you the what will the correct answer of, right? So yes, we're gonna start with the technical question.
Yes, sir. So first of all, let's start with basic question. So can you tell me what is a fluid?
A fluid is a substance which moves with the shear strain. When we apply force, the fluid moves or deform continuously for the applied force.
Okay, Naveen.
So fluid is the one which deforms continuously with the application of force.
Okay. And what is difference between static pressure and dynamic pressure?
So static pressure is the pressure which we observe in the fluid at rest rate, and dynamic pressure is when the fluid is at motion, sir. This can include the velocity gradient, the velo- the velocity pressure at 1/2 v square by 2g, sir.
Hmm.
This is correct. 1/2 v square by 2g.
No, sir, v square by 2g, sir.
Naveen, what is
So
the difference
static
between?
pressure is constant.
Yes,
Static
this is
pressure is due to the fluid is at rest. The dynamic pressure is caused due to the change in velocity during the flow of fluid.
Okay. And हाइड्रोस्टैटिक प्रेशर स्टैटिक फ्लूइड में और हाइड्रोस्टैटिक प्रेशर मूविंग फ्लूइड में ये दोनों अलग होंगे या सेम होंगे?
Just try to ask the question in English because Naveen can't understand.
Okay.
Too. So
Sorry,
you
sir.
can ask the question in both languages, right? Hindi or in English both.
Okay, so what is the difference between hydrostatic pressure in a static fluid and hydrostatic pressure in a moving fluid? Are they same or different?
एक्सक्यूज मी सर, सर अभी आवाज आ रहा है?
हाँ, अभी तो सही आ रहा है.
ओके सर, तो अभी
ठीक है, चलो करण को भी ले लेते हैं लाइन में. So you can answer also that particular questions because your subject is also fluid mechanics in the second preference, right? So you can also answer the questions what we are asking and in your turn also. Can you explain what is the fluid?
Current.
Okay, Naveen, just move forward. Okay, so I'm just asking one question. Suppose a plate is fixed. There are two plates, right? Just imagine there are two plates. One plate is fixed, the bottom plate is fixed, and the top plate is moving, right? So can you first of all tell me what will the direction of shear force on the liquid?
Yes, sir.
So can I?
Just a minute.
Okay.
So shear force will be opposite to the direction of flow, sir, on the fixed plate.
I'm just asking the direction of shear force on the liquid.
It is opposite to the direction of movement of the moving plate, sir.
Okay, Rahul.
Yes, sir. The answer is correct, sir.
The shear force on the fluid will be in the
shear
opposite
force
direction of fluid flow.
What, sir?
The direction of shear force will be in the opposite direction of fluid flow, right?
Yes, sir.
Karan, are you hear me?
yes sir, I can hear you, sir.
Can you answer this question?
So it will be opposite to the direction of the plate, sir, because we are considering the no slip condition as well.
Okay. Can you draw the direction of force in the paper and pen paper also?
Yes, sir.
All of you. Two plates are moving. Sorry, one plate is fixed and the another is moving. Okay, the bottom is fixed and the top is moving, right? And I have just asked the direction of shear force on the liquid. I'm again repeating the question. Yes, Akshara is answering in the comment box the direction of fluid flow. Yeah, there is option of notation there or no? Just allow the
What, sir?
notations.
Notation, sir, where? What are you saying?
चलो
Screen share में, sir?
कोई नहीं, मैं नोटेशन नहीं करूंगा, आप नोटेट करते रहना, ठीक है ना? जो क्वेश्चन मैंने पूछा है इनका एक बार जरा इनको एक डायग्राम इनको एक बार बना दो, शायद मुझे लग रहा है कंफ्यूज हो रहे हैं सभी लोग. There are two
Sir,
plates, one plate is
repeat.
fixed and another is moving, right? And between the two plates there is a fluid, and I have just asked the direction of shear force on the liquid. Rahul, can you show me?
Sir, I need to present from the text view, so I will like to present.
Test view. Okay,
Sir,
Sehaj,
text view.
let them present. Okay. Okay, you can present. I have to just first allow you to present, right?
Yes, sir. So just a moment.
Just present. Rahul, just present.
Sir, वो leave कर दिया, वो दूसरे से join कर रहा है.
Okay. Naveen, can you show me the direction of shear force?
Yes, sir. Shall I show in the notes, sir?
Just show me. You have just assumed the top plate is fixed and the bottom plate is moving, right?
No, sir. Top plate is moving and bottom is fixed.
Bottom plate is fixed and top is moving. And these lines, what you had represented?
The direction of shear force, sir.
Direction of shear force. So shear force will work on the surface or entire fluid?
On the entire fluid, sir. But in surface, it will be maximum.
Shear force will work on the entire fluid, but the surface is the maximum. Rahul, what's your comment on this? The shear force will work on the surface or on the entire fluid?
Sir, on the entire fluid, sir.
Okay. You have just applied the force on the top plate and the bottom plate is fixed, and you have just drawn the velocity profile,
Internal resistance, sir.
right?
Yes, sir.
And the direction of shear force on the fluid is in the opposite direction of fluid flow.
Yes, sir.
Okay.
So
So, what's the Newton's law of viscosity is saying? If you just want to apply the Newton's law of viscosity on this particularly situation, so the shear force actually the Newton's law of viscosity is for what? For the plate or for the liquid? First of all, the question is that. Naveen, are you getting my question? The Newton's law of viscosity explained for what? For
Yes,
the
sir. Yes,
shear
sir.
force on the plate or the shear force on the liquid? Rahul,
sir, for the plate.
for the plate.
Yes, sir.
करण कुछ बोल सकते हो? हमारी वॉइस क्योंकि प्रॉपर नहीं आ पा रही है लोगों के पास तक.
सर अभी आप
नहीं बेटा, रुक जा रही है बहुत, वॉइस आपकी बहुत ब्रेक हो रही है.
नेटवर्क इशू है सर यहाँ भी, मतलब लग रहा है वही है.
So shear force exerted by the fluid on the plate, sir.
Shear force exerted by the fluid on plate, right, Naveen?
Yes, sir.
Okay, so how the fluid will exert shear force on the plate, and what is the direction on the plate?
It will be opposite to the direction of the moving plate, sir.
You are saying the shear force on the plate will be opposite to the direction of moving plate.
Yes, sir.
Rahul,
So the plate will exert the shear force in its direction, and the fluid will give its resistance in the opposite direction, sir, to the plate.
so I have started with the question that the direction of shear force on the fluid.
Yes, sir.
So what are you have told?
So we have told in the opposite direction. I haven't
And,
thought in this way, sir.
and what's the actual direction of shear force on the fluid?
In the same direction, sir, of the
Naveen?
fluid.
IITN भानु बेटा मैं आपके कमेंट्स देख रहा हूँ, अक्षरा मैं आपके कमेंट्स भी देख रहा हूँ, डोंट वरी, ठीक है ना, आप अपने कमेंट्स करते रहो. Naveen, are you getting the point? The direction of shear force on the liquid will be in the direction of fluid, because the plate that is moving in the direction of fluid flow, actually the plate will exert the shear force on the liquid. The plate will exert the shear force on the direction of liquid, then there will be deformation in the liquid, then there will be presence of the shear strain, right? So I have just asked the Newton's law of viscosity is valid for the surface of plate or the plate or for the fluid. So all of you have just told. Again, can you answer? Just think again and then answer. Newton's law of viscosity is valid for solid plate or for the fluid?
For the fluid, sir.
Rahul?
No, sir. I'm not having the right answer now.
What's the Newton's law of viscosity? First of all, tell me.
What, sir?
Newton's law of viscosity.
So Newton's law of viscosity determines the shear stress that applied on the that is applied on the fluid to keep the motion applicable.
Naveen?
Sir, the shear force upon area is proportional to the rate of shear strain, sir.
Okay, so shear force on the area. Which area?
Yes, sir.
So this area.
Area that is in contact with the fluid, I think, right?
Yes, sir.
So,
Yes, sir.
so the shear force that we have applied on an area is proportional to the rate of a strain, a shear strain, right? So the strain will be the, where? Where will be the strain? In the solid plate or in the liquid?
Liquid, sir.
Liquid.
Right.
So, Rahul,
No, sir.
not getting my point.
No, sir.
Okay. चलो तुमने जो डायग्राम बनाया है इसमें इस डायग्राम को तुमने अगर देखा होगा एफएम के अंदर तो वहाँ पर जनरली एक एंगुलर डिफॉर्मेशन आता है जहाँ पर एक एंगल थीटा आता है.
हाँ,
ध्यान
सर.
दिया कभी?
Yes, sir.
ठीक है ना. तो एंगल थीटा कहाँ पर आता है, डिफॉर्मेशन कहाँ पर होता है, लिक्विड के अंदर होता है.
Yes, sir.
तो ऑब्वियसली हमारे पास जो भी आप shear force अप्लाई करेंगे दैट विल बी ऑन द लिक्विड एंड द deformation or strain will be also in the liquid. The whole law is valid only for the case of the liquid. Newton's law of viscosity is valid for the liquids
Liquid.
only, not for the solid. Right?
Yes, sir.
ठीक है, आप अपना प्रेजेंट करना बंद कर सकते हो, है ना राहुल?
Thank you, sir.
हाँ. तेज.
हाँ सर, सर प्रेजेंट कर रहा हूँ. विजिबल है क्या सर?
हाँ.
Okay. So, all of you consider a case like this is a pipe, okay, and here fluid is moving, and we have pitot tube like this, one pitot tube like this, and one tube like this, and one tube like this, and you can consider all in same level, centers of both three tubes are in same level. So if it is H1, H2, and H3, so what is the relation between H1, H2, and H3? Can you tell? And why?
So X1 will be greater than X2 and X3. X2 and X3 will be equal to each other.
Naveen?
Sir, H1 will be greater than H2 and H3, sir. Has H1 measures the both static pressure and dynamic pressure, sir.
And H2 and H3?
Whereas in H2 and H3 it will measure only the static pressure, sir.
Okay. करण तो वैसे ही और ठीक है.
करण
अब
आंसर
कैसे
कर सकते हो आप? ट्राई करो जरा, देखते हैं
Sir,
आंसर है कि नहीं.
H1 will be greater than H2 and which will be equal to 3, sir.
Why? Why?
Hello?
हाँ.
Why? Because H1 will consist of pressure head as well as the dynamic pressure head, that is the velocity head. But the H2 and the 2 and 3 part will only consist of the pressure head.
ठीक है. अब कंसीडर करो कि एक ओपन चैनल फ्लो है. There is an open channel flow. For example, in a river, volumetric flow rate you can assume m dot, and there is a tube in it. And similarly, a flow is in pipe, and volumetric flow rate is m dot. And here also a tube is inserted. Both are closed from the top. And centers of these you can also assume at same level. So here, can you tell me?
Okay, sir.
And this distance is h, and here also distance is h. Okay, so can you tell me here what will be relation between h1 and h2, and why?
H1 and H2. So H1 will give the atmospheric pressure as it is an open channel flow, so the fluid is moving with the gravity and not due to the pressure. So in the first case, we will only observe the head of the liquid due to the atmospheric pressure surrounding the fluid. And sir, in the second case,
H2 H1 में से कौन बड़ा होगा पहले ये तो फिर बाकियों को बोलने दो, फिर अपना वो देना रीजन.
ठीक सर, H2 बड़ा होगा सर.
ठीक है. नवीन एंड करण.
So H2 will be greater than H1, sir. And H1 it will measure the static pressure plus the atmospheric pressure. In H2 it will measure the static pressure plus the internal pressure of the pipe.
करण.
सर मैं ये सुन नहीं पाया सर, ये जो पहला वाला ओपन चैनल में वो आप दोनों को कवर क्यों जो है वो जो
क्या किसको कवर किया? ऊपर से क्लोज है.
It's like the barometer.
जो H1 जो आपकी बैरोमीटर.
हाँ, बैरोमीटर की टच समझ.
तो सर फिर H2 और सर सेकंड वाला पाइप है.
वॉइस क्रैक हो रहा है. नवीन, कैन यू टेल मी व्हाई डिड यू सेड H2 will be greater than H1?
Sir, in case of H2, the height in H2 will measure both the static pressure rho GH plus the internal pressure of the pipe, sir. In case of open flow, will measure only the static pressure plus the atmospheric pressure, sir. So H2 will be greater than H1.
Okay, and Rahul का भी same explanation. Okay.
Sir, but there is a difference, sir. Sir, in open channel flow, we don't measure static pressure, sir. As the thing is, कि सर मतलब कि सर ओपन चैनल फ्लो होता है सर तब सिर्फ ग्रेविटी के कारण फ्लो हो रहा है, और जो हम लोग को राइज मिल रहा है वो सर एटमॉस्फेरिक प्रेशर के कारण फ्लो हो रहा है, जो लिक्विड के साइड पे लग रहा है।
नहीं, ग्रेविटी के कारण फ्लो हो रहा है मतलब वर्टिकल नहीं है, हॉरिजॉन्टल।
नहीं सर, बट सर तभी सेकंड में हाई व्हाट सर?
हाँ, फाइनल आंसर क्या था तुम्हारा?
इससे सेकंड में ज्यादा रहेगा क्योंकि हम लोग जो फ्लो कर रहा है पाइप में से वो प्रेशर के कारण फ्लो कर रहा है, सो इट विल मेजर फर्स्ट एटमॉस्फेरिक प्रेशर एंड आल्सो द प्रेशर ऑफ द फ्लूइड, जिसके कारण वो फ्लो कर रहा है पाइप में।
ओके, ठीक है, करूँगा तो वो इसलिए ठीक है। कंसीडर ये एक पाइप है एंड दिस इज सेकंड पाइप एंड both have same area and velocity, inlet velocity is also same v, and pressure drop you can assume to be same. So but this in this fluid T1 fluid and temperature of fluid is T1 in this pipe and temperature of fluid is T2 in this bottom one, and T1 is greater than T2. So can you tell if suppose breakage happens in any one of the pipe of same, for example, a hole occurs in both the pipe of same diameter. So can you tell in which pipe economically we will get more loss? Viscosities you can assume to be same.
Sir, in the second case, the loss will be higher.
Okay, Naveen?
Sir, in the first case, as in first case, temperature is higher, so the energy supply to increase the temperature to T1 will be lost, sir.
Okay, do not consider enthalpy loss. Can you think of other factor? Another factor? In which pipe, if there is a hole of if a hole occurs of same diameter, then in which pipe we will have more economic loss? Karan, if your voice is audible.
Sir, economically it means you are trying to consider energy as well, no sir? तो फिर
don't consider enthalpy loss, and you can neglect enthalpy loss. Think of other factor.
सर विस्कोसिटी सेम रखे हैं दोनों में?
हाँ, सेम।
Sir, is fouling a part in this, sir?
What?
Fouling, sir.
Wow. You can assume delta P to be same in both the pipes.
No, we don't have to consider fouling.
Can you think of in which pipe loss of fluid will be more? Diameter is same of both the holes. Karan, loss of fluid किसमें होगा?
सर इकोनॉमिकली लॉस इसका मतलब सर आप जो पाइप है आप उसमें कुछ इश्यूज हो रहा है वो
नहीं, ये पता हो कि लॉस ऑफ फ्लूइड किसमें ज्यादा होगा अगर इन दोनों में सेम होल हो गया, सेम डायमीटर का होल हो गया। फ्लूइड बाहर निकलेगा ना, कुछ पानी बाहर निकलेगा।
सर दोनों का डायमीटर सेम है?
हाँ सेम है, टेम्परेचर अलग है। Can you relate with mass flow rate? Mass flow rate,
सर
what is the formula?
हाँ सर, मतलब वो करेंगे तो इक्वेशन ऑफ कंटिन्यूटी के हिसाब से तो दोनों में फिर सेम होगा।
सेम होगा।
Sir, is the fluid is
टेम्परेचर का
incompressible,
कोई
sir.
इफेक्ट नहीं पड़ेगा किसी प्रॉपर्टी के ऊपर।
Sir, is fluid is incompressible or compressible, sir?
You can consider incompressible. Oh, so compressible you can consider.
Compressible, sir.
Density can change. I want to say.
So if the fluid is gaseous, means if for higher temperature density will decrease, no, sir. So the velocity will increase by continuity
No,
equation.
fluid,
So losses will be
don't
more
consider
in
gas.
pipe one, sir.
It is a liquid. Okay, Rahul, you can give your answer.
So in the second case, the loss will be higher. Sir, as we are considering it a liquid, so liquid density is inversely proportional to temperature. And as we reach higher temperature, the density will be lower. And if the volumetric flow rate from both the holes is same, so in the second case, we will get more loss of mass.
Mass flow rate rho into A into V होता है, तो उससे हिसाब से बोलते हैं।
Yes, sir.
ठीक है, understood, Karan and Naveen.
Yes, sir.
Okay, sir, yes, sir.
Okay, let me add some point in there. Suppose A and B both are having a variable area, like A is in the diverging area, right? Just consider
Gate in the diverging area. Okay, sir.
A is having the diverging area and B is having the converging area.
Yes, sir.
Okay.
Yes, sir.
So
Okay,
now
sir.
what will be the effect upon the loss of fluid?
Also, so at entry, the mass flow rate is same.
Definitely. Both are having the same mass flow rate.
Sir, please repeat
Sir,
the
in converging,
I have
sir,
just
in
told
converging area,
pipe A is having a diverging area, right? The pipe B is having a converging area. The area is variable in the both pipes and the area is just different in both pipes, right? And the case is still same. Both pipes have the temperature difference, right? I think T1 was more, Sehaj.
Yes, sir.
The pipe A is having a more temperature compared to pipe 2. So there is a hole in between the any surface of the pipe. So what will happen about the fluid loss for the hole?
sir, in the converging section, due to decrease in the area, the velocity will be high. So there will be more losses due to kinetic energy. There will be more loss due to kinetic energy loss in seconds.
In
Sir, in
first or
second
second
case,
case? इसकी बात करो नवीन आप.
Yes,
In which case?
yes, sir. In second case.
The second case. Rahul,
sir, in the second case,
the loss will be more.
yes, sir.
Why?
So as we go down the streamline, the area decreases, so the pressure increases, sir. And if we make a hole in that converging section, so the loss, so at higher pressure, the velocity of the fluid will be more at the exit, so the loss will be higher.
So what is responsible for loss? Fluid loss, velocity or pressure? Karan.
sir. What sir? Sir, if the sir, means if there is a losses will occur more, means if we are considering, means the pressure is increasing from one point to another point and it is retarding, means the velocity is decreasing. So I think in those cases the losses are more, sir.
I have just asked loss का main reason क्या है? Velocity or pressure? I think this is a kind of fluid loss. Means the particular fluid have a mass and flow rate, right?
Yes.
So in any type of leakage, there is no role of pressure,
So just
right? Getting my point, Naveen?
so,
In any kind of leakage, there is no role of pressure. All depend upon the velocity, right? Was exactly mass flow rate. If mass flow rate depend upon the velocity and area also. Okay, na? So all of you just consider the converging section will have a higher velocity. So if we have the leakage in the converging section, then definitely there will be more loss. So what is the effect of temperature on both cases? You have just assumed the velocity is more in the converging section, then the loss will be more if we having a hole in that particular section, right, Karan? So what is the effect of temperature then?
sir, in the first case, the temperature is higher, so the density of the fluid is lower, sir.
First case was, I think, the diverging section, not
Yes,
converging.
sir. Yes,
Okay,
sir.
just join these two sections. Just imagine. Just join these two sections, the converging and the diverging section. Have you been getting my point? Just join these two
Yes, sir.
sections, right? A hot fluid is flowing, okay, and we have just insert a pitot tube in the converging section and in the diverging section.
Yes,
Okay,
sir.
so the head will be same or different. Which tube will have the higher head and which tube will have the lower head? तेज अभी थोड़ा सा हीट ट्रांसफर की तरफ मूव करें.
So both will
Sir,
have the same head, sir.
रिपीट करना.
So both the cases will have same head.
both
Cases will have same head, sir.
both cases will have same head. Naveen,
sir, in converging section, head will be higher, sir.
in converging section head will be
Higher, sir.
higher. How the head will be same in both cases, Rahul?
Sir, if we apply Bernoulli's equation in both points, so the total energy should remain constant, sir.
Total energy remains should remain constant.
Yes, sir.
Okay. Can you just explain the assumptions of Bernoulli's equation? Because you have just told about the Bernoulli's equation. I want to know what are the assumptions of Bernoulli's equation.
So steady flow, non-viscous fluid, and steady flow and non-viscous fluid, sir.
Steady flow, non-viscous fluid means inviscid fluid, right?
Yes, sir. And flow along the streamline, sir.
Along the streamline. Anything else? Naveen,
Incompressible fluid.
incompressible fluid. So if you are just heating the fluid, then what will be the changes there?
What, sir?
Because the fluid is hot fluid, right?
Yes.
So what will be the changes there?
So
Is
the
any
pressure.
assumption is violated?
Yes, sir. Incompressible fluid, sir.
Incompressible.
Incompressible fluid.
Yes, sir.
So can we apply Bernoulli's equation then in that particular case?
No, sir.
Naveen, Karan,
No, sir.
Sir, no, sir, no, sir. Density is changing, sir.
density is changing. Then how the head will be compared in these two cases in the diverging and converging section? Naveen, you have told the converging section will have the more head as compared to diverging section because
Yes, sir.
in the converging section the pressure will be
Velocity will.
positive pressure gradient, negative pressure gradient will be there, favorable pressure gradient there, right? So if the temperature is there, density is varying, the pressure will be constant there or there will be changing in the pressure also.
They are changing the.
If the pressure is changing, then definitely the static and the kinetic head, if we use the pitot tube in that particular section, the static and kinetic head both will also vary.
Yes.
Especially the static head will vary,
Yes, sir.
right? So we will only draw the variations of head in these particular cases if the temperature is not varying, right? Because if the temperature is varying, we can't draw the variations of the head. Okay? Because
Okay.
Bernoulli's equations assumptions are violated, and all things
Yes.
are valid only if the fluid is in the. You have to draw the variations with respect to the compressible fluid, right? If the density is varying, so that is a different parameter. है ना? तो उसके लिए फिर वी हैव टू यूज द CFDs, कंप्यूटेशनल फ्लूइड डायनामिक्स का इस्तेमाल करना पड़ेगा, देन उसके थ्रू हम इसको ड्रॉ कर सकते हैं. Sehaj, can we move with the heat transfer?
Okay, sir. So all of you consider that this is a solid cylinder, okay, and it is insulated from curved surface areas are insulated, and there is uniform heat generation G in it. And outside there is forced convection with heat transfer coefficient H1 and H2, where H1 is equal to H2. Okay, so can you draw temperature profile axially? Solid cylinder. पहले सिर्फ और first only draw temperature profile inside the cylinder.
Sir, can I show?
Yes, yes. थोड़ा नीचे करना.
Also, Naveen, just move apart from the screen because there is some blurriness. Just hold steady.
ठीक है, समझ गई.
Sir, can I?
Yes.
Window. Next view. Sure.
Okay. Okay. And Karan.
Sir, it will be parabolic in the under the cylinder, and then outside it will on both
ठीक है.
the ends.
And what happens if we increase heat transfer coefficient
Rahul,
on both the sides?
presentation बंद कर दो.
ठीक है सर. Sir, if
What
we
will-
increase,
what will happen if we,
sir, if we increase the heat transfer coefficient from both the
Sir,
sides,
both the sides by
temperature-
equal amount?
what's up?
By equal amount, we increase the heat transfer coefficient on both the sides. So can you draw it in same graph?
The slopes will get more steeper, sir. Sir, outside the two faces of the rock,
Sir, first the temperature at the ends will rise a little bit, and the slope in the convection section will be more steeper.
Naveen, can you show what are you seeing? Can you show the temperature profile?
So the temperature profile will be almost similar to the previous one, but the temperature will be lesser than the previous profile, sir.
Which temperature? And what will happen to temperature profile outside in the fluid?
Sir, it will be more steeper and temperature will be lower than the previous one, sir.
Okay. Karan and Rahul.
Seven. Window. So this one. So the second case. So as the energy generated within the solid is constant, so for remain it at steady state, the temperature should have.
Yes, surface temperature is same in both the case or different?
Sir?
Surface temperature.
तो उससे surface temperature को थोड़ा decrease करना पड़ेगा ताकि
And maximum temperature.
Maximum temperature.
Maximum temperature will remain same or it will change?
So it will increase, sir.
Increase maximum temperature.
Sir, maximum temperature will decrease, sir, because on both the surfaces the temperature will decrease because the convection is happening fast because of the increased HTC. So the max will decrease, sir.
Yeah.
Okay.
Yes, sir.
Okay. And now consider that in right side heat transfer coefficient is increased further, keeping the left side heat transfer coefficient same. Understood?
So again, sir, repeat, sir. I couldn't hear.
I am saying that now consider a case when heat transfer coefficient on the right side is increased further, but heat transfer coefficient on left side is kept constant. Now how will be temperature profile?
So it will shift towards the left.
Proper.
So the maximum temperature will shift towards the left side.
Okay, sir.
Yes, sir. Yes, sir. The maximum temperature will shift towards the left, and after on the right side of the rod, the profile will become more steeper.
Mm-hmm. And what will happen if we increase the thermal conductivity of the solid cylinder?
So even
Naveen, can you tell?
So the profile will become flatter, sir.
Flatter.
Yes, sir.
So the profile will
become flatter,
parabolic
sir.
nature will decrease, sir. It will move more towards the. It will move more towards the linear.
Okay. Okay. And Rahul?
yes, sir. It's flat होगा अपने sir.
And last, what will happen if we remove the insulation?
So even remove the insulation, sir, then sir the whole temperature will Tmax will drop by a bit, sir, and the whole graph will shift by an axis of some constant.
Naveen and Karan?
Sir,
Sir, if we remove the insulation on both sides, then sir it will behave like fin, sir.
Behave like what?
Fin. Because
Fin.
in fins, fin, sir.
So what will happen to temperature profile?
Sir, it will start behaving in an exponential. The profile will behave in an exponentially, sir. Not in this way, in the parabolic way or the linear way.
What will happen to exponential? What do you mean? Can you draw it? Naveen?
So if we remove the insulation means the the profile will change. The slope will be more, sir.
Can you draw? And Karan, you were saying fin. It will behave like fin. So how
So
the
because
temperature profile?
you are opening both the lateral surface is being exposed to the atmosphere, sir. So convection will take place from the lateral surface as well, no, sir.
But in fin, one side heat flux is constant. No?
For the fin, there should be a heat source.
Hmm. And also, you were saying exponential. There are different cases, and the case which I am talking, it is not exponential. If even you consider a fin, it is hyperbole. I think something cos hyperbole, like fin with an insulated tip. Wala case.
Sir, but a cos hyperbolic also, sir, it's a short form of exponential form, no, sir? Because if you are taking cos x e to the
Okay,
power x plus e to the power minus x by
okay,
2.
but what Sumit sir said, why it will be fin and why it will be not. Did you understand? Naveen,
What will the
can you
direction
draw
of heat flow,
what?
Karan? You are just
Uh,
saying that there is a case of fin. So what will the direction of heat flow in that particular case you have drawn on your copy? Uh, okay, let's move forward for the last question of this segment, heat transfer. Then
So
we
it
will.
will be in the direction of decreasing temperature, sir. That's the only decreasing
I'm
form of
just
heat flow, no, sir.
asking because the I think that is a cylindrical section, right? Sehaj?
yes, yes, sir.
Okay, so the direction of heat flow will be in the axial or radial direction. You have just told that the pipe will behave like a fin, right? So what will the
Yes,
direction
sir.
of
Yes,
heat
sir.
flow? Axial or radial?
So initially it will be in the axial direction, and when the removal of insulation take place, then it will be in both directions.
Okay, Naveen,
It
what do
will
you think?
So
Radially as well as
initially,
radially.
the direction of flow will be in axial, sir. When we remove the insulation, it will be on both radial and axial direction.
Okay, so suppose the same pipe is there, right? And the insulation was also there as the say has told you. Okay, remove all hot
Okay, sir.
fluid, place a nuclear rod, nuclear fission reaction is taking place, the pipe is behaving like a nuclear reactor. Then
Yes, sir.
what changes will be there for the feasibility of nuclear reaction?
Yes.
अगर
Yes,
आपको उस पाइप में न्यूक्लियर रिएक्शन करानी है तो चेंजेस क्या करने पड़ेंगे? जो लोग भी वीडियोस देख रहे हैं यूट्यूब में, वो लोग भी कमेंट बॉक्स के थ्रू अपने कमेंट्स कर सकते हैं। क्या लगता है क्या चेंज करना पड़ेगा? वी हैव टू इंक्रीज इंसुलेशन और डिक्रीज इंसुलेशन और चेंज द प्लेस ऑफ इंसुलेशन लाइक आउटसाइड टू द इनसाइड और इनसाइड टू द आउटसाइड और एनीथिंग एल्स? ये जिसके बाद कुछ क्वेश्चंस हम लोग सीआरई के भी कवर अप करेंगे, है ना? और
हाँ सर.
लेट्स स्टार्ट as much possible as much early, because I have another class also.
सर इंसुलेशन सब बाहर ही लगाएंगे बट क्रिटिकल रेडियस पे सर.
Absolutely.
यस सर.
Naveen,
ताकि
what do you
सर
think?
Sir, I do not know for this case, sir.
Sorry, just repeat.
Sir, I do not know for this case, sir.
Okay, Karan.
No, sir.
Okay, अच्छा किसी को ये पता है? Anyone know that the if any nuclear reaction is taking place in a nuclear reactor, so where the coating is placed or insulation is placed, inside or outside? Anyone have idea that how the nuclear reactor is made of? Fire clay bricks or anything else? Have you just heard about something? If there is a
नो सर.
nuclear fission reaction is taking place, then there is no need of insulation, right? If the nuclear reaction is taking place, the insulation will be never there. We use the coatings because in the case of the nuclear fission reaction, we need more of the radiation that must be reflected. Okay, so we remove the
यस सर.
insulation from the pipe and we use coating inside the pipe. So we can reflect most of the radiation that is moving towards the wall, and that will be reflected, right? That's the difference. If we are using any nuclear fission reaction, no need of insulation. The fire clay bricks we are used in the nuclear reactor. So inside the nuclear reactor, there is a coating. That coating reflect the radiation. So the heat loss will be already there. Most of the emission will be reflected towards the chamber, right? Sehaj, some questions from the CRE also. Then we will finish the session.
Okay, so theory consider that. First, tell me what is the role of catalyst.
So, catalysis substance with increase, sir.
Naveen?
Catalysis substance which alter the rate of the reaction by lowering the activation energy, sir.
Okay, and current.
Sir, it fastens the rate of reaction by lowering the activation energy and it does not participate in the reaction.
ठीक है. तो अब कंसिडर करो कि एक PFR है. There is a now consider there is a PFR. Okay, and in this PFR, reversible reaction A gives to B, reversible reaction. Okay, and it is operated isothermally. PFR is operated isothermally. So, can you draw the conversion of A versus length graph in this PFR?
Yes sir. So we have to consider.
Yes.
No sir. At initially we have pure S sir.
Pure. Initially at say 0.
So CB is also 0. The initial amount of B.
You can consider 0. It is a reversible reaction, okay? Naveen, have you drawn? Okay, Karan.
So it will be exponentially decreasing, sir.
It is reversible reaction, not. Oh, it is reversible, not irreversible. It is conversion of it, not concentration. Also, XA.
Sir, which graph have you told us to draw?
PFR.
No, sir. The graph XA versus L or concentration versus L.
XA versus length.
Sir, then XA it will be just the mirror image, no? Opposite.
Okay. So now can you draw in this same graph what will be the plot if we add catalyst in the
But sir,
PFR?
so if we use catalyst, then
Uh, Rahul, you can stop presenting. Let others do that. हाँ नवीन ठीक है करण ठीक है now lastly consider that it is a gaseous reaction. A gives to be reversible gaseous reaction, and due to catalyst present, we are experiencing a pressure drop. Okay, so now what will be the profile? And also assume that reactor length is just enough so that equilibrium conversion is achieved. Just enough.
sir, could you repeat again?
Repeat. I'm saying that now catalyst is added in the PFR.
Yes,
and
sir.
due to catalyst, pressure drop is also occurring now.
Yes, sir.
And also assume that reactor length is just enough that equilibrium is achieving. The plot which you drew earlier,
So,
na?
voice is
So
breaking.
conversion with length. Sir, voice break हो रहा है क्या?
हाँ सर.
याद आई थिंक तुम्हारे हेडफोन का एक बार बैटरी चेकअप बैटरी वजह से ऐसा हो.
अब क्लियर है क्या सर?
ऐसा लैग कर रहा है.
अब क्लियर है?
हाँ अभी सही.
So I was saying that now pressure drop is also occurring due to catalyst. What will be the plot? Firstly, can you tell what will happen because of pressure drop? It is a gaseous phase reaction.
So because of pressure drop, sir, axial mixing will occur.
Don't consider since catalysts are in powdered form. Okay, consider that it is still behaving like a PFR, ideal PFR. Don't consider any non-idealities.
Yes, sir.
Naveen, can you tell?
Sir, 1 minute, sir.
Okay. Current.
Not, I'm not getting on how to approach.
Okay. Can you tell what will happen to residence time if pressure drop is if pressure drop is there? Residence space time of the
Then, sir, it will increase, no? If pressure drop is
it is a
decreasing.
gaseous reaction.
Sir, if pressure drop is increased, sir, then residence time will decrease, sir.
Naveen and Karan.
What, sir?
Okay. I'm asking Naveen and
Sir, if there is a decrease in pressure, then the number of moles in the reaction will favor for the increase in the concentration, increase in the number of moles of reactants, sir.
Can you tell me what will happen to the space time?
Sir, if pressure is increasing, then sir, the
Decreasing.
residence time
Pressure
will
drop.
decrease, no, sir.
Pressure drop is there.
Pressure drop.
Yeah. Can you tell me what will happen to volumetric flow rate? It is a gaseous reaction. If pressure is decreasing with length, volumetric flow rate, what will happen to volumetric flow?
And sir, the pressure is decreasing, sir.
Pressure drop is there. No?
Pressure drop is
So pressure drop is decreasing or pressure drop is increasing?
No. Initially there was catalyst, and now due to catalyst, pressure drop is also there. With length, pressure is decreasing. Total pressure is decreasing. जैसे पाइप में प्रेशर ड्रॉप होता है.
Space time
Naveen,
will
can you
decrease,
tell?
sir. Space time will decrease, sir.
Space time will decrease. What will happen to volumetric flow rate?
Volumetric flow rate will increase, sir.
Okay, now can you draw the graph?
Sir, if volumetric flow rate increases, then sir, the equilibrium concentration will also decrease, no, sir, because it will not get the A will not get enough time to react.
That's what I'm asking. What will happen to the plot?
Sir,
Graph converted.
the equilibrium line will shift downwards, sir.
Okay. Okay. Naveen and Rahul, can you tell the final?
Yes, sir. It will shift downwards, sir, because it is getting less time for reaction, so it will require more length for reaching.
Okay. Okay. Okay, sir.
Okay, so guys, just let me conclude this session. As per your performance and as per your preference of order, I have just noticed what you have just told us as per your concepts, right? So Naveen, your preference order is FM is your strongest subject, but I feel somehow concepts are lagging. Okay, so try to emphasize more practically, right? Focus on practical concepts, so how the variations will be there. If there are some variations, then the how the things will be vary, right? As the Sehaj has asked that particular questions where the pitot tubes are there and the temperature variations are there. Okay, na? So such type of questions will be asked, and this is the type of question which was asked earlier in the bar contribution, right? This is the type
Yes, sir.
of question. So it's FM is satisfactory, but there are their improvements are needed, and heat transfer is your third preference of choice. So it's okay as per your preference of choice. Current heat transfer is your first choice, right? So as per the discussion, the questions you have just answered are good, but I think just think once again before the telling the questions, ठीक है ना? ओवर कॉन्फिडेंस अच्छी चीज़ है, लेकिन थोड़ा सा ट्राई ये करना कि सामने वाले को जब भी आप आंसर करो तो थोड़ा सा एग्रेशन ना लगे, ठीक है ना? तो ये थोड़ा सा ट्राई करना, और बाकी ठीक है। एफएम के कॉन्सेप्ट भी आपके ठीक हैं, सेकंड आपका सब्जेक्ट है, एंड द सेम थिंग फॉर द राहुल। आपका एफएम भी ठीक है, कुछ चीज़ें लैग कर रही हैं तो उनको थोड़ा इंप्रूव करने का ट्राई करना। हीट ट्रांसफर ठीक है आपका, अच्छा है, ठीक है। करण और राहुल आप सेम लगभग लेवल पे हो, बट ये ध्यान रखना कि सेम लेवल पे क्वेश्चन अगर आप दोनों आंसर करने जाओगे, बिकॉज हम सेम क्वेश्चन इसलिए आप लोगों से पूछ रहे थे कि वैसे ही सेम क्वेश्चन आपसे वहां भी पूछे जाने वाले हैं। जैसे मैंने न्यूटन्स लॉ ऑफ विस्कोसिटी जब पूछा था तो समी ने आंसर जो दिया, नवीन, when I asked the Newton's law of viscosity, so all of you have answered the similar way, but अगर जिसका आंसर को डिफरेंट वे में आएगा, इफ यू आर जस्ट आंसर्ड इन अ स्पेशल डिफरेंट वे, देन द चांस ऑफ सिलेक्शन विल मोर, ठीक है ना? तो रेट ऑफ शेयर रेट ऑफ स्ट्रेन का क्वेश्चन होता है, ये तो सभी जानते हैं, तो बुक्स के अंदर में लिखा हुआ है, बट एक्चुअली आप उसको कैसे एलोबोरेट करते हो, ठीक है ना? कई बार आप रेट ऑफ स्ट्रेन को वेलोसिटी ग्रेडियंट बोल जाते हो, कई बार आप बोलते हो टाउ इज प्रोपोर्शनल टू डी यू अपॉन डी वाई, तो इस तरह से रिप्रेजेंट नहीं करना है। रेट ऑफ स्ट्रेन के हमारे पास अगर सॉरी शियर फोर्स अगर रेट ऑफ स्ट्रेन के प्रोपोर्शनल है तो उसको इस कंडीशन में है, ठीक है ना? तो वो कंडीशन भी समझना जरूरी है, ठीक है। तो जब तक फ्लूइड आपका स्टेडी नहीं है तब तक हमारे पास में क्या है, आपका वेरिएशन शियर फोर्स और रेट ऑफ स्ट्रेन में भी आ सकते हैं। तो कुछ टर्म्स अगर आप और इंक्लूड कर देते हो तो चीजें और अच्छी हो जाती हैं, मैं ये कहने का टर्म बात कर रहा हूँ। और एक चीज हमेशा ध्यान रखना, जैसा कि सेहत ने भी आपको बताया होगा, ठीक है, कि आप इंटरव्यू अपने अकॉर्डिंग ले जा सकते हैं। आप उनको वही क्लूज, वही टिप्स एंड वही पॉइंट्स दीजिए जिससे आप सोचते हैं कि आपका नेक्स्ट क्वेश्चन हो। इस चीज को थोड़ा सा ध्यान रखना, राइट नवीन? ट्राई टू कन्वे द इंटरव्यूअर एज योर ओन पेस, राइट? तो ट्राई टू स्पीक दैट पर्टिकुलर वर्ड्स which you have knowledge about. Don't use
Yes,
any
sir.
such type of word which we don't have you don't have knowledge, right? And you are just got stuck on that particular words, okay? तो चलो इस सेशन को आज हम लोग यहीं से फिनिश करते हैं, ठीक है, अच्छा है, बट अब इम्प्रूवमेंट का नीड है। आप लोगों का शेड्यूल कुछ फाइनल हुआ अभी तक इंटरव्यू का? क्या
Yes,
स्लॉट्स
sir.
हैं?
Sir, 27.
27। करण तुम्हारा क्या है?
Sir, 27, sir.
27। एंड नवीन योर्स स्लॉट फॉर इंटरव्यू?
29.
29।
29, sir.
ओके। एक बार अभी अगर बीच में अगर टाइम मिलता है तो आप सेहत से फिर से कनेक्ट करके आप लोग इंटरव्यूज कंडक्ट दे सकते हो अपना मॉक, अगर उसके पास टाइम होगा तो, बिकॉज आफ्टर 20th ही विल बी आल्सो बिजी विद सम प्रोजेक्ट वर्क, ओके? तो उसके पहले अगर कुछ भी अगर आपको इम्प्रूवमेंट का नीड है तो आप ग्रुप में भी होगे ऑलरेडी सभी लोग, तो वहाँ पे डिस्कशन कर सकते हो, ठीक है? तो चलो आप सभी को ऑल द बेस्ट, ठीक है?
Thank you.
इम्प्रूव करते रहो लगातार, ठीक है? रिजल्ट कुछ भी हो, इस होप के साथ में वही जाना है कि यार मैं दे पाऊंगा आंसर, नहीं दे पाऊंगा। क्वेश्चन आपके सामने आता है तो उसके बारे में सोचो, क्योंकि अगर वो क्लूज देंगे तो उसको भी आंसर आपको पकड़ना पड़ेगा, ठीक है ना? तो बेस्ट ऑफ लक, एंड बस मस्त तरीके से कूल होकर के इंटरव्यू देना और प्रिपरेशन करते रहो। अगर यहाँ पर नहीं होता है बाई चांस एनी हाउ अगर, तो बहुत सारे और ऑप्शंस आपको इन फ्यूचर भी और मिलने हैं, ठीक है? चलो फिर, और जो
Yes.
लोग भी हमें यूट्यूब में देख रहे थे तो आप लोग भी इन क्वेश्चन से एक ये सीख ले सकते हो कि किस तरह से क्वेश्चंस वहाँ फ्रेम किए जाते हैं। जो भी आपने पढ़ा हुआ है उन कॉन्सेप्ट्स को ही अप्लाई करना होता है, लेकिन वहाँ पर जब वेरिएशंस होते हैं उन कॉन्सेप्ट्स में वेरिएशंस भी आपको आना चाहिए, ठीक है ना? तो चलिए इस सेशन को आज हम लोग यहीं से फिनिश करते हैं, और आपसे कल मुलाकात करेंगे हम लोग एक नेक्स्ट सेशन के साथ में, जहाँ पर सेहज भी होगा, शैलेंद्र सर भी होंगे और मैं भी रहूँगा, और कुछ नए फेसेस के साथ में, कुछ नए क्वेश्चंस के साथ में आपसे कल मुलाकात करेंगे एक न्यू सेशन के साथ। तब तक आप सभी को गुड बाय, थैंक यू एंड टेक केयर, एंड थैंक यू सेहज फॉर योर पीस अवेलेबल टाइम, ठीक है?
वेलकम सर।
और आप लोगों को बेस्ट ऑफ लक सभी को, एंड थैंक यू।
Thank you, sir.
Thank you, sir.
Thank you, sir.